Okay, what we're going to do in this vodcast is take a look at basic atomic structure. So we're going to look at the mass number, the atomic number, and then our three subatomic particles, which I'm sure you've all heard of already: the protons, the electrons, and the neutrons. So let's take a look at the first one. We're going to look at protons. So let me get my pen back here. Okay, the one thing you want to know about the protons is that they identify the atom. So let's say, for example, we're talking about something that has 6 protons. That's carbon. Now it might be carbon 12, it might be carbon 13. It doesn't matter how many neutrons are present, or for that matter, how many electrons are present. If it has 6 protons, it's the element carbon. That's very important. Protons identify the atom. Our protons are located in the nucleus. They have a positive 1 charge, and they have a mass of 1 AMU. You could think of the mass as simply 1. AMU stands for atomic mass units, and we'll talk about that in more detail in a later vodcast. The number of protons is determined by the atomic number. So for example, we're going to write symbols that look like this. So what we'll say is the atomic number is that number. We're going to say that number is the mass number, and we'll talk about this later. But when you're looking at an atomic symbol, the atomic number identifies the number of protons. Alright, let's take a look at our next subatomic particle, and we'll look at neutrons. Neutrons are going to be used when we talk about isotopes. And again, we've mentioned this a number of times, and we'll keep mentioning it. Neutrons are located in the nucleus. They have no charge, so sometimes their charge is written like that, or sometimes it's just written as a 0. They also have a mass of 1 AMU, so we'll say a mass of 1. To determine how many neutrons are present in an atom, you're going to take the mass number and you're going to subtract the atomic number. So for example, let's say we have magnesium with a mass number of 25 and an atomic number of 12. Remember, the atomic number tells us the number of protons. The mass number is going to tell us the number of neutrons plus the number of protons. So if we wanted to know the number of neutrons in this particular atom, we would take 25 minus 12 equals 13. So there's 13 neutrons in that atom. Again, we said the number of neutrons is going to determine what isotope you're talking about. So for example, we might have 2 different magnesium atoms. Magnesium 25 and magnesium 24. So this isotope would have 12 protons, 13 neutrons. This isotope would have 12 protons, 12 neutrons. 24 minus 12 is 12. 25 minus 12 is 13. So when you're trying to determine how many protons are present and neutrons are present, you're simply looking at the mass numbers and the atomic numbers. Alright, let's take a look at our third subatomic particle, the electron. Now for us, the electrons are going to be arguably the most important, and the reason are the electrons determine the chemistry. So when atoms bond together, for example, when hydrogen bonds with oxygen and another hydrogen, the things that keep these 2 atoms bonded together are the electrons being transferred. So in a typical type of bond, the electrons might be transferred completely. In a different type of bond, the electrons might be shared. But it's those electrons that are determining the bonding, which is what chemists study. Electrons are located outside the nucleus. So if our nucleus is here, our electrons might be circling somewhere out here. And we'll talk about that structure a little bit later also. They have a -1 charge, and they have essentially no mass. The mass is actually 1/1800th the mass of the proton, but for our purposes we consider the electron to have no mass. To determine the number of electrons in an isotope, for example, our isotope of magnesium 25, we know the number of protons. Neutrons was 25 minus 12, or 25 minus 12, which would be 13. The electrons are going to be the same as the protons in a neutral atom. Now this is important because what we're going to talk about are atoms with charges, but if there's no charge on this atom, the electrons equal the protons. Now that should make sense because if the protons are +1 and the electrons are -1 in terms of charge, if you have the same number, 12 positives, 12 negatives, they neutralize each other, so the overall charge of the atom would be 0. Now we'll talk about when it's not 0 in a little bit later. Alright, so what we have then, and I've been kind of drawing these throughout, are what we refer to as nuclear symbols. Nuclear symbols can be written a few ways. The first type is this way, where we said that's the atomic number and that's the mass number. You can also write this like that. Lithium 7 is what we call this. The reason we don't write the 3 there is because lithium always has an atomic number of 3. Like we said, the atomic number identifies the atom. So if we say lithium, we automatically know we're talking about something with 3 protons. And I'll show you how you're going to identify that off the periodic table. On the other hand, the mass number can be different. This happens to be lithium with 4 neutrons. You could potentially have lithium 8 with 5 neutrons, or lithium 6 with 3 neutrons. So you can write nuclear symbols this way also. What we'll talk about a little bit later is symbols on the periodic table. What you see is thorium here has a mass number of 232.04. Now you might say, well, if protons are 1 and neutrons are 1, how could the mass number possibly not be a whole number? And what we're going to say is that that mass number is the average mass of all of the isotopes of that element. We'll talk about that and calculate that in a future vodcast. Alright, let's talk about ions now. And let's use our magnesium example. And we're going to use magnesium 25, so things are a little bit different. If we're counting protons, neutrons, and electrons, we would say our protons here are 12, our neutrons are 13, and we would say our electrons are 12 because it's a neutral atom. But let's say we took away 2 of those electrons and we had 10 electrons. So now we've got 10 negatives and 12 positives. So we've got 2 more positives than we have negatives. That would give this atom a positive 2 charge. So what we're going to do is we're going to put a 2 plus right there, sort of like a superscript. So what this would mean is that this particular isotope has 12 protons, 13 neutrons, and 10 electrons. Now let's say you had something like, well, let's use oxygen for example. 16 and 8. Protons, 8. Neutrons, 8. Now let's give it a 2 minus charge. Our electrons would be what? If we've got 8 protons and there's a 2 minus charge overall, that means we have to have 2 more negatives than positives, so we would have to have 10 electrons. So when you write nuclear symbols, you have to identify their charges, which would identify the number of electrons present. And we'll use these quite a bit. Alright, when you have a positive charge, we refer to that as a cation. It's not pronounced cation, it's pronounced cation. And when you have a negative charge, we say it's an anion. So for example, let's say we had carbon 13, its atomic number is always 6, and this wouldn't normally happen, but let's say we put a 2 negative charge there. How many protons, neutrons, and electrons? Protons 6, neutrons 7, electrons 8. If it's a 2 minus charge, you have to have 2 more negatives than positives, so we would have to have 8 electrons. If by chance, and again this wouldn't normally happen, let's say it has a 2 plus charge. 6 protons, 7 neutrons. Now our electrons would be 4 because we have 6 positives. There's 2 more positives than negatives, so we would have to have 4 electrons. Okay, that's basic atomic structure. What you should know from this is the 3 subatomic particles, protons, neutrons, electrons, their charges, their masses, and their locations in the atom. You should be able to write nuclear symbols, and you should be able to write them as cations and as anions. This part is very important because as we write formulas, we're going to use these charges to help us write formulas.